Welcome. Thanks for joining us today. This is Nick Bowitz with Veriface. Today we're going to look at the Report Updater module of the ADT Workflow Enhancement Suite. Earlier we looked at processing files through either single weld or multi-weld, and then I hinted at the idea that you can save that ADT file after you've updated any of the indications. Maybe you've moved some cursors, maybe you deleted some indications, maybe you put your own comments in. Go ahead and save that with any name you want. Keep the ADT extension, and we're able to use this Report Updater module. There's another extension of this, the Data Viewer, that we're going to skip over in this video, but you can actually run both simultaneously, but we're going to go ahead and break that out so it's comprehensive in its own video. The idea of automated reporting has a couple of definite benefits. For one, there's a number of essential variables related to phased array that the code and maybe your procedure require you to document, and anything that can be digitally extracted out of the file, by doing that way you're going to ensure that it's accurate. It's going to save you the time of manually entering those into your report. It's going to save time from opening files and confirming things when we can just automatically extract it and know it's going to be true. There's also a number of things that we've put databases in that aren't necessarily in the report of the OmniScan, things like the gap of the probe, the recommended sweep angle of the wedge, and we'll see all that as we go. If you use your own template, you can still utilize this because we do stay in that Excel environment. So you'll see some of the imagery we do is quite neat. You get that data quality verification from the scan check portion. Is also live in our reporting. So there's a number of benefits to using the automated reporting. So with that, we'll just go into it. We've saved a 4-group ADT file. We went through, deleted the indications that we found non-relevant, updated a few of them, and then we went ahead and put a comment at the end of them. So I'm going to go ahead and open that file and kind of just talk through a few things on that. As I said, when you get done with the table, you can just save it. But to show you here, we had X number of indications when ADT got done processing. We decided to keep these 12. I went through, updated a few of them, and then I've added the flaw characteristics on the back. When you do that, you can delete any of this if you want, any of the ADT populated stuff, but I just left it in there. It's all up to you. Once you go to the update, you really have full control of that. You can delete that out or save it, whichever you want to do, whichever is relevant and nice and neat for you. So I saved that. We can go to the data. We can save that. We'll save it as the same name at the same place and just say yes, overwrite. You don't need to save it again. So with that, I'll go into the ADT module. And we've already covered these three. We're going to go to Report Updater, and the next video is going to be Data Viewer. Let's go Report Updater, just telling us we can produce basically those two files that we mentioned already. Navigate to our file. Very similar setup to the single weld. We don't need much information. Software is going to do the work for us. We just want an Excel report, and please open it for us. The cloud peak and volume we've kind of skipped over to this point. Pull up a little graphic for you guys. So here's the three laid out. So cloud, peak, and volume. Cloud's going to look basically a recreation, ADT's recreation from what the data looks like on your instrument or in your OmniPC file. Peak is going to be a more simplistic representation of the indication, just showing where the highest peak is. So if you just kind of want a basic report or the person wouldn't understand the cloud information, you can go with that. Especially if you have a lot of indications, this one can get a little busy. Here I can still tell I have 2 subsurface indication, maybe slag, and 2 that might be lack of fusion even without the volume of the indication. And then volume is exactly as you think it. It's just a not actual representation of the data, but just the volume representation, and then that is amplitude based, so I can still kind of tell how much amplitude each one of those indications has. So that's really it. We're going to stay with the cloud for this purpose. There's some customizable parts that we'll skip over for now, but you can choose some images. You can add your own custom parts, but we're going to see that in the report. So Go ahead and hit start. Reporting really only takes a few seconds, which is a huge benefit based on the value you get out of all the things that we extract. Generating that report now, and it's going to go ahead and auto open it for us. So we have a lot of the normal information we've seen before, the software versions and that, but then beyond that is very good automatic part and weld configuration details come out. We have our data quality metric listed there. As far as data quality, we have an immediate confirmation that ADT didn't find any issues as far as data dropout or loss of couplant, that kind of thing. So that's a good added value to it. It's kind of running scan check at the same time. And then we had the file detail, which is going to give us our base parameters here that we could look and compare to the scan plan. Was the probe in the right place? Did the scan start at all the same place? What resolution was it acquired at? Just some real good summary at the top there compared to the procedure and what it documents. And then we have basically an overview of the images so you can just get that first glance at what might be going on. So again, we use the cloud reporting here. We can see probably a lack of fusion here, a couple slags, a little small slag, maybe an ID indication, OD indication. And then we've got C-scan and B-scan, again customizable, but these are all amplitude based colored, so I can tell, you know, this one here might be higher indications. And they're also volumetrically correct to each other. So very reminiscent of old UT reports we had to manually draw out, but we're going to do it for you. And then we have scales on everything, of course. And then we're just going to repeat that for the other groups. I can tell immediately that group 4 did not have any indications. And the great thing about all this, if you just want one image to throw into your template, you can easily grab that. If you just want, you know, pieces of this, you can copy and paste into your own reports. So there's some customization available, but if you just want to run the whole report and do it that way, you can do it too. So we go over the Essential Variables tab. Again, the code and maybe your procedure requires you to document several of these parameters, so we make it easy on you. Some things we're not going to be able to extract. So in this case, on the OmniScan, if you don't use the probe ID, the serial number is not captured, so you'd have to manually enter that, as well as the probe manufacturer doesn't come across. If you use the probe ID, both those would be filled in for you. But we have everything about the probe and wedge, including some of those more elusive parameters that people asked about a lot. What's the manufacturer's recommended sweep? We went and created our own databases. What is the gap of the probe? Went ahead and put that in. These are code requirements that often we see aren't on reports because they're not easy to find information. And then anything like groups, digitization, so we even break that down. You know, you might be setting your points quantity in your scale factor, but what's the end effect of that? We break that down into an A-scan sample resolution for you. We also have all your acquisition parameters based on the scanner or encoder you're using, your sensitivity levels, and then those user-defined values. So we're actually able to go in there and you can actually save this. So if you're on the same inspection or require the same things documented, there's no extra steps, or you can go change the ones you need to. We have a number of select from a menu, then fill in the blank, or like this guy here, I can put in a custom field where I've custom put in message, and then ever cheery, have a great day. If I go over one more, this is really the breakdown. So this is the exact same indication table that was in the OmniPC or the OmniScan file. We see a lot of the same elements, including the surface and location, the sizing. But really the huge benefit here that you don't get on the OmniPC file is these quick stats. So we parse that information. We're going to tell you how many total indications, how many are above certain threshold values, which one has the highest amplitude overall, which one has the highest ADT score or confidence level. And then if you want to know which one's the longest, which one's the tallest in through wall height, or which one's has the most width, we're able to break that down for you as well very easily. And even if they're ID, OD, or subsurface in nature. We have a nice concise table there. We always have the code sheets for the major codes, ASME, AWS, typical rejection levels. we can kind of see in one quick glance that there's probably not any ASME rejectable here. A few are probably AWS. And again, the benefit being of that is this is all in Excel, and we can get rid of that, delete it, do anything. And then really the value added, again, also from the after save, is the comments I've put in here about what type of defect it was. The rest of this is really just the micro level. So individual groups have their own quick stats related to each group, and we can kind of break it down a little bit more. We can see which ones had the most. If we remember from earlier in this video, group 4 had no indication, so its stats going to be pretty simple. That's really it. I mean, it's just a very accurate and efficient way to get the required procedure and code information out directly, make sure it's accurate, and then kind of parse the information in different ways so that we can immediately communicate it. Thanks again.